So here we go. I came up with a really bland title for this, Make Money by Making Stuff, but manufacturing as an industry in general is effectively that. It is essentially creating some kind of product that exists for the betterment of society or for a consumer interest or good. And in order to do it, there are a variety of careers that go into the manufacturing world, but the three central to them are the production or operations groups, the people that are actually running the equipment that make the product, the maintenance group that essentially is in charge of making sure that the equipment stays up and running and that everything works the way it's supposed to, and then the engineering group that is there to find a way to make the system better, to assist maintenance or production if there's issues or hiccups along the way, because that is a nearly daily occurrence in manufacturing, and to find new and better ways to do the same types of processes. And the reason I'm here to talk about it is that has been the last 10 or 11 years of my career, primarily spent in manufacturing. I have a mechanical engineering degree from Saginaw Valley State in Michigan. And before that, I had a degree in meteorology from St. Cloud and minors in Spanish and journalism, which it doesn't seem to be a lot of tie in there. I thought I was going to be a TV weatherman. I actually went back to college in my mid-20s to get the engineering degree. But I was fortunate in that meteorology is mostly fluid mechanics applied to clouds in the atmosphere. And to turn that into fluid mechanics in the engineering world was a pretty easy transition academically. So let's see if I can get my slides to work here. So that's me working back in 2016 when I was at Flint Hills Resources at the Pine Bend Refinery, that big giant lit up factory that's on 52 as you're heading up towards the cities. I've worked most of my career in petrochemicals. I'm a licensed mechanical engineer in the state, which means I am able to do work on any public project or sell my services as an engineer to any client that's interested. I currently work for a consulting firm called SEH, and I just recently transitioned to that job after spending most of my career in the physical plant environment. But in addition to being a consultant and a project person, I've also been a designer, a troubleshooter. I have been an operator for equipment on the production line. I've been an emergency responder simply because when things go wrong at the plant, usually it's the people that are physically closest to the incident that end up being those most responsible for trying to get things back together and responding to issues. As an engineer, I've also been a planner trying to figure out how to operate the plant most efficiently. There's a big strategy piece to it as you get further along in your career, deciding what the company should be investing in to improve the plant environment. And I think this ends up being true of a lot of engineers in general, but I've been pushed very often into leadership positions, either de facto as a manager for a group or just within a small team environment, the person who ends up taking charge just by virtue of knowledge, experience, and I guess the push towards being a problem solver as an engineer. So that's a little bit about my background. For those on the line, if you're willing to come off mute, when I look at the audience, are y'all more interested on the engineering side, maintenance, operations, or all of the above? I'm going to kind of go through all three elements of it that I've had personal experience with. Feel free again to stop me or chime in if you want me to spend more time on any one topic or another. I'm going to kick this off with a YouTube video about manufacturing. It's just a quick little 2 to 3 minute overview. Let me know if the sound doesn't come through. Let's see if this plays out.
typical shift for me is like I come in, I go into what we call a laboratory, and I walk around and I talk to the technicians and I make sure they have everything they need as far as just understanding drawing, checking out the parts, packing everything from chemicals that they need to do different processes. We do a lot of calculations on our fit to see whether or not we're making things at the correct speed. And we have what's called design, and they basically design a lot of the satellites, different parts of it. And sometimes their drawings aren't totally clear. My job as a technician says, hey, I don't understand this drawing. Then I have to kind of interpret it or figure it out or call the designer and see if he can explain it to me. And then after I understand it, I'll go and try and put it in layman's terms to the technician. I maybe don't apply like everything that I've learned in calculus and algebra, but I just apply like not giving up on a problem or sticking with it, or just because it's difficult, I don't give up. The classes that would have helped me in high school probably were obviously the math classes, even though I was bad at it. English classes, because you do a lot of writing. You do a lot of just writing emails and stuff. And you don't want to sound dumb. Have to write to the manager or somebody else's manager. I like interacting with people and helping people. If I was like recommending anything to high school today, I would take as many classes as possible and take different things so you get into everything and you can find out what you really like.
Excuse me. The reason I wanted to share that is that, it's from the perspective of a young engineer, and there were a number of elements to that story that echo with my own. First, he started in JUCO and then eventually went into engineering. It wasn't his first choice, nor was it mine. But it's not something where you have to go 4-year college, graduate at 22 or 23, and go straight into the engineering world and kind of follow that very well-beaten path. There are plenty of people that have gone into this field starting off as an operator straight out of high school. You go get hired, start that summer, you work for a few years, and maybe you get the interest in going to school at that point. Number of operators that I used to work with at Dow Chemical were out on the production floors, like 600 people in the operations group at this factory. And a handful of them were going to school for engineering during the day and then working the evening shift in production. And while I think that might have been a more difficult path than simply starting school right out of high school, they had the benefit of earning a full-time income while going to school. They were essentially able to pay for their classes as they went. And by working on a manufacturing floor, they were coming out of school with something far better than any internship. They already knew how to run equipment. They knew how to go through the manufacturing processes. They understood the culture in manufacturing. And so it's one of these fields where there are so many different ways to get into it, and there are so many different jobs available that you don't have to take one prescriptive path to get into the engineering field. A couple other things that stood out to me in that video that I want to kind of highlight. It was very much a team environment. You notice that there wasn't one person doing everything. It was operators, engineers, the maintenance crews are always circling around the equipment. And you have a very collaborative environment. And that makes it really fun because if you're at all a social person, you have this opportunity to be in a very team-oriented environment all day, every day. And yet, if you're less on the social side, more interested in the heads down type of work, there are myriad opportunities in that end, especially around automation. Get into that in a little bit here. But just his story, I don't know if you guys caught it. At one point, he notes he wasn't good at math. And while it certainly helps when you're going through the coursework to be good at math, there's a certain innate draw to that. You don't have to be an expert at math and science to be a good engineer, because at the end of the day, most of what we have to do professionally once we're out of school is just problem solving. It's figuring out new ways to do things and to effectively communicate. So what is manufacturing? I won't belabor this point too much, but it can be any one of a number of things. These are just a couple of screenshots of random places that I've worked, but it might be in a refinery where you're taking crude oil, literally mined from the earth, piped into the state, and then converted into gasoline, diesel, asphalt, you name it. These are relatively autonomous plants, but the operators that are there are responsible for making sure that we don't put a 2 mile wide crater in the ground if something gets upset in the process because of the flammability and the hazard of what you're working with. And they're also incredibly complex operations. So for everything that's going on out here physically, as oil is processed into its different derivatives, you have an operator whose primary job is more like a video game, working in the control room, monitoring all of the equipment to make sure the pumps are doing what they're supposed to, that the temperatures and pressures are accurate. And to that degree, it doesn't feel like your traditional manufacturing like you might see in some of the how-to videos where it's people on the floor using their hands, making a part, turning screws, whatever. There's a lot of different ways for a manufacturing career to look, if you will, depending on the industry that you get into. So there's a pretty broad spectrum, but there's more manufacturing out there than you realize. And I guess I'm here to say that it's alive and well in America. You hear in the media about the industrial decline, the Rust Belt, all the jobs that left the Michigan and Ohio areas as the automotive industry kind of contracted and largely got outsourced over the past 40 years. And same is true on the Iron Range. But there is a lot of manufacturing that's still done in the United States. And for the longest time, everyone said, well, automation is going to kill jobs. There won't be jobs on the factory floor. And 40 years in, robots have not won that war yet. And instead, what happens is that we end up with a lot of jobs that end up with a higher skill level or more training that's needed to be effective in them because you're doing the programming for the robots, you're doing the maintenance on them, or you're engineering the systems to run in an autonomous fashion. So there's really, it's changed jobs to get involved in automation, but it hasn't completely eradicated the hands-on labor as we understand it. And the other thing is that these are really old school jobs. You think about, in the 50s and 60s, it was a very noble thing to go out of high school. You didn't go to college. You went straight into one of these types of jobs, whether it was building trades, operations, what have you. And those people are hitting retirement age. And so those jobs are becoming available, and there simply isn't the pipeline of people coming in behind it. And so I would say for the past decade, everywhere I've worked, it's just a constant now hiring sign. They're always looking for talented people, and there's a chance to go in and, maybe you haven't settled on exactly what you want to do. Maybe you know exactly what you want to get into, but for anyone who hasn't really made up their mind, if you walk out of high school with a GED or high school diploma, you head into a plant, you can spend 6 months there and you'll be opened up to this entire new world of different career paths. And that there's a lot to be said for that, especially because you're making money on day one to get into it. A couple industries I think that are very key, not just to today, but 10 years, 15 years down the road, where I think we're going to see a lot is food manufacturing. That continues to be a major piece of the US economy. And it's something that you can't really outsource. We grow a lot of food here in the US. It's going to get processed here, and the final product is going to get shipped abroad as we export. Automotive, we've seen a huge resurgence in US automotive. And one of the reasons is a company that I pay a lot of attention to, and I think a lot of people do, and that's Tesla. Their first gigafactory wasn't theirs. It was originally a GM and Toyota factory back in the 80s and 90s. And as GM and Toyota ended a partnership that had them making a couple of cars under the same, essentially, engineering design, they sold the plant, Tesla bought it, and this is where the Model S is now made. And if you think that automation has taken American jobs, just take a look at all the cars in the parking lot. That is thousands of people that are gainfully employed. And it's an example of how, as one sector starts to decline, either new sectors emerge in that space or new companies come in and find ways to do it. And the other is that as we get into the next step of the Industrial Revolution, if you will, which starts to involve Internet of Things, artificial intelligence, those are the high-tech jobs and the high-tech industries that we do a ton of here in the United States on the engineering side. And it's getting easier and easier to do that manufacturing here as well. So, no, we don't have as many jobs per capita as we probably did 60 years ago when we were first starting to get into automation, and US manufacturing was essentially the dominant force, not only of our economy, but globally. There's still a lot of opportunity, and the opportunity that's out there is high tech, really fascinating stuff. Um, threw a flow chart on here of the various things you can do if engineering is what you want to get into. So it pretty much starts with a 4-year degree. There's a barrier to entry that you got to pay for tuition. University of Minnesota, I think when I looked it up today, it was $50,000 for a 4-year degree, roughly. Once you get your degree, you might be on the production floor as an engineer whose sole job is to make sure that every day the production team hits their quota, that they make enough of whatever it is that they make, and that they do it cheaply enough to continue to push the company further along in profitability, safety, efficiency, you name it. A lot of people like myself will go into the design engineer world, and that essentially is figuring out the next thing you're going to make, whether it's designing the equipment, designing the product that is going to be made by the company. Others will go directly into the maintenance field to support the maintenance teams, the techs that are out in the field doing the actual repairs. Usually there's an engineer component to that to try to figure out ways to keep something from breaking again. It happens all the time in manufacturing where the same part breaks over and over and over again. And the maintenance engineer will go in and find a way to design a new part or a different way to process it so that you don't have that same issue. And then you get some that go straight into the project world, and their job is to essentially take what the design engineer has created in their mind and find a way to get it built, get it installed, get it tested so that the production engineer can take over and start making product. Eventually you do these jobs for long enough and you get promoted, your career progresses, and maybe it's, you become a manager for that group. That's a very common path. Project managing can be interesting because you might be running small projects and then you might be running major plant expansion projects, building the next gigafactory, if you will. And eventually you may decide that production is more entertaining than engineering, and you could go that path. But regardless of which way you go or how you get there, the red line is my last 10 years of career. A lot of people, once you get later in career, if you don't end up staying in one of these fields, and I know people that have been a production engineer for 20, 25 years because they absolutely love it, couldn't imagine doing anything else. You might end up running the plant, you might end up being a consultant that starts telling other people how to run the plant. The reason I would say to get into it, if I were to encourage anybody on engineering, it is such a versatile degree. You can go just about anywhere, do just about anything with it. You have to get your 4-year degree, but the initial income, your starting salary when you get your first job is going to be a comfortable one. And it's going to be one that should put you in a position to be able to pay back your student loans and get yourself into a good position financially long term. Maybe most importantly, it's high demand. If you go out on Indeed right now and you Google, mechanical engineer, electrical engineer, civil engineer, the number of jobs that are open right now is just staggering. And if anybody's interested, my own company is going to be doing at least one internship this coming summer. So once you get some college education, there's always internship opportunities as well. I'm going to touch on one little thing too, and this is kind of an interesting tidbit about engineering. You can stay as an engineer your whole career, or you can get into the business side. And if you have an interest in running a company, running a business, consider this. 45% of the Fortune 500 CEOs out there have some kind of STEM degree, and many of them are engineers. I think it's at least a third of CEOs, including some at probably the biggest companies in the United States, are engineers. I'm going to give Elon Musk a pass here for only having a physics degree, but clearly a penchant for engineering. And the list is longer and more distinguished, but these are people that have obviously, kind of hit the pinnacle with their companies. And a lot of people in the business world will listen to engineers and respect engineers because of the problem-solving skills that you learn early in your career, and the fact that you end up being central to how the business runs and how things get made. That same line of thinking can progress. Basically, it serves you well throughout your career, I guess is what I'm trying to say there. But let's say the 4-year degree is not for you. This is probably one of my favorite fields, and if I hadn't gotten an engineering degree, this is probably where I would have ended up. Maintenance, you can sometimes get into it right out of high school. Often you're looking at a 2-year degree to get the basics, whether it's a boiler operator license to be able to run steam systems, or it's technical experience in how to take apart a valve and put it back together, how to essentially assemble, disassemble, and autopsy equipment that fails. Maintenance ends up being the paramedic for the plant. They're the ones that come running out when things break. And a lot of times the entire plant is standing around waiting for the maintenance person to do their job well. And they can be very lucrative positions as a result of that. Random caveat in the state of Minnesota is the boiler operator. Most manufacturing operations, most large buildings all use steam for heating. That steam is generated in a boiler, and the state requires you to have a license. It's a relatively easy one to go get. If you have a 2-year degree, usually comes with the boiler operator license, and then you can become a production operator in a steam plant, and that carries a state certification requirement, but the salaries jump a little bit because of that certification. Obviously, the 2-year degree is usually a little bit cheaper. RCTC, it's about 20 grand to get your full credits for a 2-year degree. And you can get right into the maintenance world. And a lot of times, because again, this is a very hands-on position, you do it for 10, 20 years. As you start to break down a little bit and get a little bit older, there are a lot of jobs that stem from it where you become the person that knows the most about the facility. You become the go-to technical expert as a specialist of sorts. You can always go the supervisor manager route as well. Another thing that I've seen happen quite a bit is that somebody gets their 2-year degree, they spend some time as a maintenance tech, and then they go get their engineering degree, similar to the operator that I was talking about before. And again, you're making money while you're going back to school, and there are a lot of options down that path. Last career I'm going to touch on is production. And this is the one where you go out of high school, or let's say you down the road you decide to make a career change. You can get into it right away, and there are constantly jobs open. Now, they aren't always the best paying jobs starting off, but if you're 18 and you don't want to go to college right away, you don't know what you want to do, this gives you the chance to get into the career, gain a lot of experience, have a whole bunch of options kind of put in front of you, and you're making money while you're going through it. And this is one of those paths that I don't recommend everybody to go down, but if you don't have a clear path in front of you, you don't know exactly what you want to do, getting into production or operations, being the person on the floor that's actually making the product, there's a very fulfilling element to that. And again, you can go just about anywhere with it because you can always slide over and get a 2-year degree or get a 4-year degree. It's technical work, it's hands-on, and it is extremely high demand. These are jobs that are constantly available. There's a lot of promotion opportunity because of that. And again, as a lot of the older employees are starting to retire, the number of people coming in behind them is not growing. And so again, these opportunities are kind of ever present. Let's see, we're 25 after, got 5 minutes to take questions. I'm willing to hang around a little bit longer. I don't have anything lined up right after this. So I guess at this point, I will open the floor if there are any questions from the audience. If you'd like to reach out to me beyond this conversation or ask more in-depth questions, feel free to reach out to me at any point. I've got my email address, my phone number. You can reach out to me on LinkedIn if you want to. You can stalk my profile and see what some of those specific experiences I mentioned were, but I'm really passionate about manufacturing. It's been a great career path for me, one I have enjoyed thoroughly, and it's a very lucrative one as well. Again, when you look at the barriers to entry, they're relatively low, especially if you're starting off in operations or maintenance, and the career paths are nearly endless once you're in the field. And it's something that I think is actually going to grow in America over the next 5, 10, 15 years, just because of the amount of stuff that's been reshored, the amount of automation and artificial intelligence that's going into things, and just the sheer opportunity from the retiring workforce of 20, 30 years ago and the lack of people that have come in to replace them so far. It's really a fantastic opportunity. So I'd like to thank you all for spending some time with me. Again, if you have any questions, feel free to reach out.